Hi, this is Pre-Algebra Lesson 3-4. Describe proportional relationships, constant of proportionality. Last lesson, we described proportional relationship focusing on the equivalent ratios. In this lesson, we're going to describe proportional relationship um, focusing on the constant of proportionality. So we'll be able to use the constant of proportionality in an equation to represent a proportional relationship. And we'll use equations to solve problems involving proportional relationships. Let's look at the solve and discuss it. Jamal can run 1 mile in 5.05 minutes. If Jamal maintains this pace during a 5-kilometer race, he expects to break the course record of 15.25 minutes. Is Jamal's expectation reasonable? Explain. So first, identify important information. 1 mile in 5.05 minutes. That's his speed, and he's going to maintain this pace during the whole race. And the whole race is 5 kilometers. Do you notice anything that's weird? You have a mile for distance for your unit, and you have a kilometer for your race. So how much is a mile? How much mile would there be in 5K? Would be the first question we're going to ask. Okay. And he has a goal. He wants to break the course record of 15.25 minutes. So he wants to run the whole 5K in 15.25 minutes. Is his expectation reasonable? Well, in order to compare if it's reasonable or not, we first need to know how many miles would he run total. Okay. So yes. So in order to convert 5 kilometers to miles, you need to know the conversion rate. If we let m be the number of miles in 5 kilometers, we can use the conversion rate. 1 mile is equivalent to 1.6 kilometers. So using the same rate, we're going to convert that to m miles for 5 kilometers. So those should be equivalent ratios, correct? In order to solve for m, you multiply 5 on both sides. And you have 5 divided by 1.6. 1.6, which is equal to just m. 5 divided by 5 is 1. Okay. 5 divided by 1.6 is 3.125. So you know that the whole 5K race is how many miles? 3.125 miles. Okay. Using this information, what do? Well, we need to set up a proportion to see if he maintains this pace, will he be able to finish it in 15.25 minutes, right? So we're using, now we have a 5K race. We're going to use the speed, right? How many minutes? He runs 5.05 minutes, and he runs 1 mile in 5.5 minutes. 0.5 minutes, right? And you want to set up a proportion that's equivalent to 5K, which is 3.125 miles. So 1 mile becomes 3.125 miles. And if he continues the pace, same pace, the proportions should be equivalent, right? So how many minutes? We can set that be a variable x. And so x could be how many minutes he needs in order to complete the 5K, which is 3.125 miles. In order to solve for x, you multiply 3.125 on both sides. And you should be able to get x by multiplying 3.125 times 5.05. And x is equal to 15.78125 minutes. So is he reasonable to set a goal of 15.25 minutes? 15.78 is more. time than 15.25. So what can you say? If he continues this pace, he cannot break the record. He needs more time to finish it, or unless he runs faster, right? So conclusion, at this pace, Jamal will take more than 15.25 minutes to run 5K. So his expectation is not reasonable, right? He either has to speed up his pace in order to break the record, or he shouldn't expect to break the record, right? So let's look at focus on math practices. Assuming that Jamal runs at a constant rate, how does his pace describe the time it takes him to finish a race of any length, not just 5K, any length? How would you describe it using his pace? You can use the rate, right, as how much time he takes in order to run a mile. And you can multiply that rate with any number that needs to be like a constant, right? That needs to, in order to get the expected distance. And then you solve for the proportion, right? Just like how we solved the problem. So you can first write his pace as a rate, time over distance, and then you can multiply it by the length of any race to find the time it takes to finish that race, right? Just like we did. If you multiply distance, however distance, 3.125 was 5K. So if you multiply your 3.125 is your goal distance times your unit rate 5.05, because 5.05 minutes would be 1 mile. So if you multiply that by how many miles you're running, that's just how much it takes in minutes, okay? So let's think about how we can represent a proportional relationship with an equation. Example 1, writing an equation to represent a proportional relationship. A sponge is an example of a filter feeder. It takes in food by filtering water through its body. The sponge maintains a constant flow of water through its body. What's an equation that represents a proportional relationship between the time and the amount of water filtered? So look at the sponge in this picture. Water in, water out, water in, water out. The sponge can do that. The sponge can filter water at this constant rate, which is 8 liters in 10 hours or 12 liters in 15 hours. So you can write that as a ratio as well, right? The constant of proportionality is a constant multiple that relates proportional quantities x and y. It's the value of the ratio y over x, and it's represented by k. So first we need to write the ratio, which is going to be liters over hours. And we have 8 over 10, 12 over 15, and they're gonna be equivalent to 0.8. That is our constant of proportionality, K. And this K is is going to be y over x because that's how we figured out k, right? In the first place, we divided y by x, liters by hours, right? In order to get k, which is 0.5. So that's the equation that we used already. And using this equation, if you multiply x on both sides, we get kx is equal to y. And we can also say, oh, y is equal to kx. And does this look familiar? It looks like a linear equation with a slope k, right? So you can use this equation to represent the relationship between time and the amount of water filtered, right? So y, which is liters, will always be 0.8 times the hours, number of hours, okay? So that's our linear relationship equation. Let's try this question. Maria made 2 batches of fruit punch. The table at the right shows how many quarts of juice she used for each batch. Write an equation that relates the proportional quantities. Okay, so we have apple juice, 5 and 10, grape juice, 8 and 16. So every 8 grape juice would be 5 grape apple juice, right? So dividing y over x, we have x over 5, which is 1.6, and 16 over 10, which is also 1.6. So the constant of proportionality is, the k is 1.6. An equation that represents this proportional relationship is y equals kx. So y equals 1.6 times x. Okay? How does the equation change if the amount of gas juice is the independent variable x and the amount of apple juice is a dependent variable y? So what if we change x and y? So what if we switch these two? We're going to get a different constant of proportionality, which is 5 over 8 or 10 over 16, which is equivalent to 0.625. So what's our equation? The equation is y equals 0.625x. Okay? Our k would change to 0.625. So the equation should be y equals 0.625x instead of 1.6. Okay. Example 2, solving problems using an equation. We know we're given information that 1 inch is equivalent to 2.54 centimeters. How many centimeters long is an 18-inch ruler? Okay, we're going to write an equation to represent this relationship. So what's our constant of proportionality? First, we need to figure out the constant of proportionality. 2.54 centimeters per 1 inch, okay? And we're going to represent centimeters, which is y, and x be the inches. So that's our constant of proportionality, 2.54, okay? And we can say y is equal to 2.54 when x represents inches, y represents centimeters. Okay, and then we're going to use the equation to find the length of the ruler in centimeters. So y is equal to, this represents centimeters, right? So 2.54 times how many inch? 18 inches would be 45.72. So the ruler is 45.72 centimeters long. Okay, so first we can write an equation using our constant of proportionality. Make sure you're mindful of the variables, what the variables are representing. Okay, if you switch the variables, if x is centimeters, y is inches, you will get a different constant of proportionality. So they matter. Let's look at this try question. A florist sells a dozen roses for $35.40. She sells individual roses for the same unit cost. Write an equation to represent the relationship between the number of roses, X, and the total cost of the roses, Y. How much would 18 roses cost? So we can first write an equation. We already have the variables assigned to us. Y is going to be the total cost of the roses, right? Which could be 35.40. So that could represent Y. And the number of roses would be X. So the constant of proportionality K is Y divided by X. So what's our K? 35.40 for dozen roses. Dozen is 12, right? So 35.40 divided by 12 is 2.95. So write an equation first. Y is equal to 2.95x, okay? And how much would 18 roses cost? You need to plug in 18 roses in your x. 2.95 times 18 would be 53.10. So you can say 18 roses would cost $53.10. Okay, $53.10. Example 3. Determine whether y equals kx describes a situation. Can you represent the total cost y for admission and x rides at the amusement park using an equation in the form y equals kx? Explain. So look at this picture right here. Welcome to Fun Fair. Admission is $20. Each ride is $5. Step 1, we're going to make a table that shows the total cost. One ride will cost $25, including admissions. If you ride 2 rides, it will cost $30 total, including admission. 3 is 35, and so on. We compare the ratios. 25 over 1 is 2.5, 25. 30 over 2 is 15. 35 over 3 is 11.67. Is this proportional? No, the relationship is not proportional, so it cannot be represented with an equation of the form y equals kx. It needs a different form. But the question just asked you if this could be represented in this form. You can just say no. Try question. Balloon A is released 5 feet above the ground. Balloon B released at the ground level. Both balloons rise at a constant rate, which means their rate is going to be the same. Which situation can you represent using an equation of the form y equals kx? Can we represent balloon A with y equals kx, or balloon B is y equals kx, or both, or neither? All right, so first we need to see if they have the same constant of proportionality. Okay, if time is x, height is y, our constant of proportionality for balloon A will be 9 over 1, 13 over 2, 17 over 3. Do we have the same k? So k is undefined, right? 9 and 6.5, and it's just going to be different. So we don't have a constant of proportionality for balloon A. So we cannot write this as an equation of the form y equals kx. Look at balloon B. Do we have the same constant of proportionality? What's y over x? 4 over 1, 8 over 2, 12 over 3. 4 over 1 is 4, 8 over 2 is 4, 12 over 3 is 4. Now we have constant of proportionality, k, which is 4. Can we write this as an equation? Yeah, if you have k, you can write this in an equation of the form y equals kx. Right? So you can say, you can represent balloon B as y equals 4x because it has the constant of proportionality k equals 4. Balloon A does not have a constant of proportionality. So it does not have a proportional relationship, which means we cannot write this in a proportional equation, y equals kx. Okay, so whenever we have the ratios of two constants, two variables that are equivalent, we can write it as a constant of proportionality equation, y equals kx. Okay, let's summarize our lesson. In this lesson, we've learned that two proportional quantities x and y are related by a constant multiple or the constant of proportionality k. And you can also represent a proportional relationship using the equation y equals kx. That was lesson 4, describe proportional relationship using constant of proportionality. We'll continue with the next lesson in the next video. Bye.